Right, some first impressions of this version of the mini mill. Various different manufacturers seem to be making it. This is called the 550 watt mill from a Chinese manufacturer. I think they're all Chinese. I think 550 watts is the input wattage of it. I don't for a moment think that the motor on here is that much bigger than the motor that you would find on the Clark or any other mill. No way really of telling, but I'm going to assume it's about the same size. It's not a brushless motor, it's a brushed DC motor with variable speed control, which I'll turn down. Variable speed control, direction control, stop button, fuse on the side. I've taken off the plastic cover, but there is a plastic cover that protects the drawbar, which is what holds it in. This one supposedly came in two sorts, MT3 and R8 taper on the spindle. Unable to supply the R8 taper one, so I had to take the MT3 spindle taper. I quite like the fact that the handles on it are made out of turned alloy, so they're quite nice feel, a nice finish to them on there. I've adjusted the jibs so there's no play on any of the dimensions on here. You've still got quite nice easy movement on that, which I think is the x-axis. The y-axis is quite stiff. I've made that stiff. Maybe that's laziness. It just felt right for me to make that quite stiff. That's nicely machined. One interesting point that I noted was that you've got very nice machined surface there, but it's not a bearing surface, and the bearing surface is rather rough in there. But I'll live with that because it does. These actually move reasonably smoothly. Hopefully I'm not going to crash into the tool while playing with it. You do on this one have a drainage point if you did have any coolant on it. I've trammelled the, or wherever they are, I had a magnetic thing, the table at about, I don't know, 6 inches away from the spindle, to reduce as much as I could just by tapping the column any out of alignment there, to try and make sure that that is vertical in that plane. It seemed to be fairly vertical in the other plane, so that's been trammelled in so that it's approximately right. And I will look at putting a plate onto the back to stiffen up that rotating joint, because I don't think I'm going to be doing that. I may look at other alterations to it, but basically it's a mill. I got it from the Chinese supplier. It cost whatever it cost. So shipped from the UK in a matter of a couple of days, so the shipping speed was excellent. Really, really good delivery time. So I totally recommend that. And it comes as it is there. Just don't expect anything super from these low-cost mills. It's the geared drive one. It's the brushed motor, so it's not the super, but it's also rather less in terms of pounds than the super. One little issue I had was that this ring here, the preload nut, which has a reverse thread, so it tightens in an anti-clockwise direction onto the spindle. Well, it wasn't tight, it was loose, it was very free. Anyway, it's been turned anti-clockwise to tighten it, and then the spindle run, which I think has an effect of tightening some more. And there is a little grub screw in there, and so what I've done is tighten up the grub screw, locking it in place. Now I have no idea what the preload tension should be. I'm told or read that if the preload is too large, then the spindle will run warm, and it runs freely enough. Doesn't seem to present any. That's with the play, there's no friction, tension in there, just turns nice and easily, and there's no movement of the spindle up, down, anywhere. I can't creak it or move it in any way. So presumably, at least it's locked on now, so it won't be spinning off in mid operation. So that's one little thing sorted on this mini mill, where we've managed to get it into a functioning condition. So here we have this low-cost Chinese mill, very similar to the Clark CMD 300 mill, also the X2 mill, not the Super X2 but the original X2 mill, Sieg X2 mill. Some minor differences are they only have 3 set screws to tension up the jib screws. I do like the handles, I've said that before on them. This is the bottom casting of the base, quite substantial. The column is a casting. I've taken the plate off the back so you can see it's actually hollow down the column at the back, but still quite a heavy bit of casting, and the thickness of the depth inside is that there's that much meat underneath the dovetails on it. It's clamped up quite tight now. It's been trued up on there. Almost useless scales. It does say, you know, the angle it's set to is about 0, but you know, it would say that and you'd still be several thous out. So that's not much use. The horizontal scale there, well, I don't know, might be of use for something, but I don't know what use it is. But there we have it, a fairly simple, straightforward on-off mechanism. Red and green buttons to turn it on, forward, reverse switch, variable speed control. Pushing that in locks it in the off position. It is a no volt release switch. I have checked that, so if you take the power off and then put the power back on, then it is in the off position as it starts. And I've taken the plastic cover off the top of the spindle there, and there is a metal cover that goes on top of the motor, which is off at the moment, and a little cover that goes on the fine feed, which goes to the device that controls the pinion to drive it in the Z-axis direction up and down the rack. So that's it, that's the deal. I am not able to directly compare it with the X2 or the Clark machine, but I'm sure it is fairly similar. It's a very rough test of the machine. It's just a piece of scrap aluminium, clamped the way it is. Clearly you've got potential for this to vibrate, but what I'm hoping is that we can just see that it does what it's meant to do in some ways, i.e. it cuts through a metal. With an appropriate end there. Right, well, not the hardest of metals to cut, and what I've done is I've done a step cut. There's a bit of roughness there if it's in focus, which is obviously due to the fact that there's plenty of movement and variation, but we've got a coarse cut there, and as some say, if you use a climb milling operation and go back again, you could presumably clean up that cut. That thing. Oh dear, not very good there. Let's stop again. Well, that's the end of this cut here. That depth there was done with a single pass at a reasonable speed. I've just been back the other way, and depending on how clean you need the end result to be, what you've got there is rebate, and these two bits here are not particularly well clamped together. They're just held by a couple of rivets at that end. As I say, if I step back from it, what you can see is it's just a piece of scrap angled aluminium clamped in there, and I've just done an experiment to see how well I can just cut in aluminium. No measurement, no setup, just clamp it on and take a couple of delicate test cuts to see that it will work. My very first cut that I did was just through a sheet of aluminium clad plastic material, sort that I use for some building projects on the garden railway, and I just machined off the some of the aluminium there. It's obviously not a level and flat piece of sheet, and that was just using the end mill, doing that very shallow cut into there just to practice using the dials and practice doing some cutting on the machine. Nothing highly technical or scientific there, but just checking that this low cost mini mill, equivalent size to the X2, actually works and seems to do a job.